And like I said, this is Deb Nutt and Marion Prince with Data Driven Classroom Activities.
Hi, I'm from Sawyer, Michigan, which is in the southwest corner of Michigan, almost to Chicago. I've taught math and science from middle school to high school, and now I teach at the college level. And my passion is STEM, so you'll understand the activity that I will be presenting. Go ahead.
And I'm Deb Nutt. I am in Salina, Ohio, which is sort of out in the middle of nowhere, farm country on the western edge of the state. I taught every level of algebra that our school provided, from basic algebra at the high school level all the way through the honors algebra 2. Became a T-cubed instructor in the mid 2000s, I guess, or 2000s, and have really enjoyed it, doing all kinds of conferences and things like that. Our agenda and our plan for today is to go through at least three, or talk about at least three different topics and activities that both of us have used in our actual classroom. One's called Tied Up in Knots, and in that, I'm going to look at maybe a different way of finding lines of fit. Then we're going to look at something using the CBR, excuse me, with the what goes up must come down, and then talking about automobiles and how much is that car in the driveway. As we're getting started here, and I'm going to try to share my screen. Oh, I just hit the stop the video instead of sharing my screen. Continue with the question that was asked about where do you think you are in your comfort and ease and knowledge of the 84 and using the 84. I've seen quite a few responses already that you feel fairly comfortable. We've had everything from 1s to 5, but a lot of people are right about in the middle. So hopefully as we go through these activities, maybe you'll learn something new about the 84 as well, and the different ways that we can do some of the things that we've done in the past. So this first activity is called All Tied Up in Knots. I've done it in my Algebra 1 class, or at the end of the linear chapter. It is a linear idea. I've done it in my Algebra 2 classes as a review of linear. So it can be done in all different kinds of classes. The idea behind it is to look at the relationship between the number of knots in a rope and the length of the rope. What I did to start this, and again, I did not come up with this. I stole this from some workshop that I went to, many years ago. It was probably at least 20 years ago, as far as that goes. I went out to the local hardware store and to our TSC store and bought about 5 different sizes of ropes, everything from about the size of a clothesline all the way up through something about the size of your thumb. Wouldn't want to go much bigger than that. This is a piece of rope that I have here at the house. Much bigger than this, because if you get it too big, by the time you tie 3 or 4 knots, then you're out of rope and you don't have very much data. I like this activity from the standpoint, it was quick and easy. We could collect the data in class and then do all of our work basically within a class period. So a few students had to finish it up at home if they weren't quite done with some of their analysis at the end. But the collection of the data, getting it into the calculators and things like that can easily be done in a class period. This particular time and this worksheet that I have showing for you here now talks about getting a length of rope. They're going to work as a group. I usually had 3, maybe 4 people in a group. I had these different size of ropes and started out with everything was the same length. I had 100 centimeter ropes. I then, in another year, went and got some different lengths of rope as well. So I had a bigger variety of data that was collected. So they had to measure their rope, tie a knot in it, measure it, tie a knot in it, and then they just filled out their chart. So it didn't take very long. I got the meter sticks from the science department. So it was a rather inexpensive activity as well, as far as that goes and stuff. Once they did it and collected their data, the activity goes on to talk about analyzing the data using the 84, reminded them of how to put their data in with the stat, get an appropriate window, make their scatter plot. I talked about looking at the scatter plot and writing conclusions at the scatter plot. One of the things that I would do more now than when I used this one a couple years ago would be to talk about looking just at their table. I realized that I was weak in not having them analyze the data in the table, and I just took the data and went straight to the table. But trying to get that multiple representations and getting them to look at all of it. And once they had that, then there was typical questions and things like that with it. So any comments or anything that I need to know, Marion, as far as
I
things are
don't see any
concerned?
questions. A lot of people are enjoying the sessions and are learning a lot at the
All right,
conference.
well, that sounds good. All right, so going to our calculator, I guess I should show this. What I did, that rope that I had shown you just a moment ago, I did collect some data. I started with 0 knots. It was 100 centimeters long, and I put 6 knots in the rope, measured it each time. So this is the data that I'd come up with that particular rope. And this is what I was talking about. I would now say, okay, looking at your table, what are some conclusions that you could make? Hopefully they would talk about what is the domain, what is the range, what is the independent, what's the dependent variable, does it look like it's linear, is it constant, is it got variation, all of those kinds of things, just looking at the table before we go to look at the data itself. But once we've collected the data, then we're supposed to go into our calculator and come up with our graph. So what I've done to save a little bit of time here is I've sort of preloaded it, some of the settings and stuff, but we'll talk about them. If I was in the Algebra 1, we might have to do this and talk through the process. I always told my students there were 3 things they had to do before they could hit their graph key. First one is to enter their data by using the stat key and then the edit key. And you can see that I have listed that data that was in my table. In my L1, I have my 6 knots from 0 to 6. In L2, I had my 100, and my shortest length of rope was the 45.8. So I've just preloaded those in there to save a little bit of time rather than typing them in and hitting enter and going through that process. So I've entered the data with the stat key. Right? Then I would go with my second stat plot, because I have to decide what kind of graph I'm going to make. When I do second stat plot, it takes me into, okay, got to turn it on. So since it's flashing, I hit enter, decide which type of plot that I want. We have a scatter plot. We have a connected scatter plot. Those of you that do statistical things, you can do your histograms and box and whiskers. We want just a scatter plot. So make sure that that's darkened. What do you want the x-axis to be representing? Did I want it to be my L1, my number of knots, or my L2, which was my length? Of course, the number of knots is our independent, so that's L1. The length of our rope was L2. I don't have that many pieces of data, so using a larger symbol, and I like the color blue, so that's good. So I've turned on my plot by using the stat plot feature. And then the third thing we always have to do is set up our graph itself and the size of our graph. And I was never a big one, especially in the Algebra 1 and the basic classes, of using a zoom stat feature. Because so many times when you do zoom stat, when you are actually using real world data, you're hanging around out there in quadrant 1 and you have absolutely no idea where you are. I always had my students set up the size of their graph, just like they would if they were using a piece of paper or graph paper. They would have to figure out, what does each of the lines on the graph paper have to represent? How often do they want their tick marks? How far out are they going to have to go? So I always had my students use the window key. It also makes them think about, what is the domain and what is the range? How much length are they going to have on the x-axis? Another rule that I always had in my class, so that the axes would show up, is they had to use negative numbers for their x and y minimums, just so the axes would show up. So that took care of that zoom stat of hanging around out somewhere in quadrant 1 and you really didn't know where it was. So I've set up my window. My minimum was -2. My maximum went to 13. I only had 6 knots. I went a little bit beyond in each of those. Don't have that many, so a scale of 1. Right? Then my y's from -5 to 120. Okay, a scale of 10. So I've set up my window. Okay? And once I have done those 3 things, I've entered my data with the stat key. I've turned on the plot with stat plot. I've done the size of my graph with window. Then I hit my graph key and I get a lovely scatter plot. Right? So again, one of the other things I'll mention, those of you that do have the Smart View, and that's what I'm using to show you this, or the computer application of it, you will be getting a emulator state for those of you that have it, and it's part of the links that you'll get at the end of the session, that will have all of this preset for you. So you could load this into your Smart View and know what they are. You can go back through and look at the video and get the windows and things like that too. So again, once they have their scatter plot, write some conclusions. But again, what we're really looking at is, okay, now that we have this lovely thing, and hopefully now they're talking about, oh, it's negative. Maybe they talk about being an inverse relation and all of those kinds of things, looking at the scatter plot, is we want to come up with a line of fit. And one of the ways we could come up with a line of fit is just to use the y equals. We know it looks linear, so I could type in just 1x and say, okay, is that a good fit? Do the adjusting, flipping back and forth between the two screens. But I've also learned that there is a really nice thing in the calculator called the manual fit, and it works for linear equations. So I want to talk a little bit about that. And again, if maybe in the chat, if you would jot down, if you've never heard about manual fit, this is something new, just to give us an idea of where we are. Okay, so to find the manual fit, I'm going to use my stat key, and I'm going to go to the right, which goes to the calculate, which is where all of the regressions are. And again, in the lower levels, the beginning of things, I don't want to do a regression because I want the students, I'm trying to connect what does that slope and the y-intercept mean in relation to the line. And if I just do a regression, it gives it to me. Okay? And the manual fit is at the end of the list, so I could scroll all the way down, or I could go up arrow and get to letter D, which is manual fit. And manual fit, again, will work for linear equations and only for linear equations. But it is a quick way that we can find a good fit right on our graph screen itself. So I'm just going to hit enter to enter the manual fit little application. I want to store my equation. Of course, if we're going to go through the process of doing this, we might as well store it. So alpha trace is the easiest way to get to our different y equations. So I'm just going to store it in y1, and then I go down and highlight the word calculate. And when I hit calculate, it takes me back to the graph screen. I have a cursor now in the middle of my screen, and I've got these points listed down below with an instruction that says to drop point. If I use my right, left, up, down keys, arrows, it moves that cursor around. And notice that as it moves it around, it's giving me different x's and y values. It's telling me where I'm at on my grid as far as things go. But I also notice that it's in blue. And since my points are in blue, I want to try and change that. Okay. So since the style is written right above the graph key, I'm going to hit graph, and I'm going to change the color of my line. And you can pick any color that you would want. I'm just going to make it something other than blue. I'm also going to make it a little smaller so that it doesn't cover up the points as much. Okay, so I've changed it to red, and I'm going to move it over to what may look like a good starting point for, oops, wrong way. I wanted to go up and I went to the right, for a line of fit. And again, it doesn't have to be perfect, but okay, that looks like it might be a good point. So I hit enter. Doesn't look like anything has changed until I start to move away from it. And when I move away from it, I start to get now my red line, and I can move this line around until I find what would be a second possible point. Okay? And if I think that is a good point, okay, then I would go ahead and hit enter again. And I'm going to pick this particular point just so I can show some other things about the manual fit. So I hit enter, and I get a complete line drawn in there. My points are now no longer listed underneath my graph, but up in the left-hand upper corner, I now have an equation. This particular equation right now is y is equal to the negative 8.979x added to 103. So it gives me the equation of that line. And if I am satisfied with that, I can hit the done, which is right above the graph. So again, I could hit the graph key and I would be done with my work. But I look at this, I'm going, I remember her talking about in class that if I'm going to have a good line of fit, I should have about the same number of points above my line as below my line, or I should try to get through several points on my graph from my line. So I'm not sure that this is really a good line, that maybe I'm a little high with it. So what do I need to change? And again, in your chat, if you want to, would I change my negative 8.9 number, or do I need to change the 103 number, since my line looks like it's a little on the high side? And all I have to do to change whichever one I choose is toggle right and left, and whichever one is highlighted, I would be able to change that particular value. Okay, so which value have they been saying, Marion, hopefully, that I need to be changing here?
Yeah, you're gonna have to, I don't see, I, 103, I see.
Okay. All right. So I need to change the 103. I think maybe I just saw somebody, because I took a moment and looked there. Someone said maybe even use a 100, got a suggestion for it.
Yeah,
So if I
'cause
use
that's,
a y-intercept of 100, all right, that did move it down. It looks like I'm going right through a few points as far as that goes. Right. So I can adjust even in this equation. And just to, again, to show it, I'm going to change my slope number. Instead of having so many decimals, I don't need to, be that accurate. I could, okay? And so let's put in and try maybe a -9.1, change it a little bit and see what that does to the angle of my line. Okay, well, that's not too bad. So you can adjust. Once you've picked 2 points and you put in a possible line, you can still make adjustments by using the equations at the top. And one time I had a student say, well, is my line good enough? I said, you have to, decide. You're the mathematician. And then I had 2 boys that were on the football team, and they were going, well, mine's more accurate than yours because I have 2 decimal places. Well, his buddy wasn't going to be outdone by that. So then he went to 3 decimal places. So I had equations where slopes and intercepts and things were like 4 and 5 decimal places out, because they got into these little contests. So I'm going to be a better person than what you are and a better mathematician. Okay? But once you are done with it and you are satisfied, then you just hit the graph key and it graphs it in. It shows you what it looks like. That, notice the equation's gone, but remember we said to store it in Y1. And so it's now in Y1, and I could still adjust it in Y1 if I wanted to. But looking at this and using this manual fit is just another way that we can come up with this line of fit with the technology, rather than going from y equals and typing it in, then having to hit graph. That wasn't a good fit. Going back to y equals, typing something in, going back to the graph, seeing what it looks like and things like that. So this will work for linear data. The other thing that I will say and show you is, oops, went too far. You are one of the slides that you will be getting a copy of. Here's a little description and a way to remember maybe how to work with the manual fit. Again, you use the stat calc until you find the manual fit. Then using it, you drop your first and last point, just you moving the cursor around. Once you have done that, you can adjust the slope and the intercept with that equation in the top left. And then you enter to store your equation in the y equals. So that is the activity that I did. Lots of different reasons that I liked this activity. It was quick and easy to do in the class. It was inexpensive. I could have a variety of graphs. I may have had my students collect the data in groups of 3, but then each student did it. I could, like I said, the first time I did it, everyone started with 100 centimeter lengths, but then I went back and I got some 80 centimeter ropes and 120 centimeter ropes, so that I even had variety. And then I could even then pick like 3 ropes, show a graph that a group had come up with, and hold up 3 ropes and say, okay, which rope do you think that particular graph came from? So that they could look at the equation and say, oh, well, that one had a y-intercept of like 81, so it's got to be one of the shorter ropes, so let's pick that. And so it makes them think about what that information means and stuff like that.
yeah.
So questions, comments? Sorry, Mirren.
Well, I asked everybody if they, because I find this activity very interesting, because your slope is negative, and usually linear data activities have positive slopes, like stride length and, distance traveled. So I
Yeah,
didn't
that
know
was
if
one of the other
anyone
reasons that I
else.
really like this activity. It was one of the few things that I found that did have negative information. There are a few sometimes that you can find in books.
Oh,
As
Burning
far as that
candle.
goes, there was always a thing about like sucking on candy and, you know, and weighing or measuring the size of a piece of candy. And then you know, hold it in your mouth for 30 seconds and then you measure it again. But that can get sort of messy and long and things like
I was
that.
gonna
There was a
say.
quick and easy way to come up with a negative relationship in the real world of things and not just something out of a book and stuff like that. But then I also had the questions at the end of what is the slope for this particular representation mean? What is the y-intercept and what does it mean? So hopefully getting them to say, you know, that's what we started with when there were 0 knots, that for each knot, my rope should shorten that particular length. And then I also had them use the prediction. And if you were able to tie 12 knots, what would your rope length be? And they were to show their work,
If you
they
could,
could
if
use
you
their
could
calculators,
actually
and
tie
eventually we talked
12
about that.
knots.
Yeah. Well, and again, if you were able to, and my particular case when I did it, and if I would go and look at it, if I were to use my actual graph and I would trace on my line, I'd be down in the negative numbers.
Right,
So
right.
again, mathematically, it may not work, but they can at least know, are they putting it in for the X or do they have to put it in for the Y to solve and that kind of thing?
But I love it when students are connecting the mathematics with the physical situation.
Yeah. All right. So if there is no other questions or comments about tied up in knots, we'll let Miriam talk about what goes up must come down.
Okay.
Yeah.
Let me try to get, I got to get the right screen.
Yeah.
I did hit share. Oh, I don't see it yet.
I say I had to hit share a couple of different times, different
Oh,
places.
really? Okay, let me try again. Here we go.
There you go.
All right. Okay. This was turned out to be a different type of activity that I never expected the kids to take it into, but it turned out to be a neat way to discuss measurement of time, because what we're sending up the ramp is a cylinder. Could be a can of soup. I used an empty container of oatmeal, and I also was able to bring in physics to my math class, and I love doing that. But I want to show you the video on the left and explain a little bit about why time became so critical in this activity. And I hope you can see it. I don't know if I can. That's a little bit too much. I'll leave it as it is before I mess it up. And notice that I can control and collect the time data, and notice how the timestamp is indicated, because that will be an issue. That became an issue in our classroom. The video on the right is a different method. I used a ruler instead of a foam board, and I also had smaller numbers. So I made the numbers bigger for this particular video. But notice that now I've got both of them going at once. But you can see how you can gather negative and positive data. And notice, I don't know if there are any questions so far.
Not so far. You're okay. Keep going.
It was approximately 10 degrees of the tilt of the ramp. And I had some students use their phone to collect the time data, and it turned out to be a little bit more difficult because the timestamp didn't have decimal portions of the seconds. So they had to use their estimation skills and critical thinking skills as how to figure out where the cylinder was at between, say, second 6 and second 7. And I had one enterprising student, he took it home and put it in his video editing software, Camtasia, and this video editing software does their timestamp in 60ths of a second. In other words, 60 frames per second. Whereas the phone, I think the default is 30 frames per second. And the other difference between the video on the left and the video on the right is the fact that the video on the left is slow-mo, because if you play it, you can see it blinking. And so it is slow-mo, even though it doesn't look very slow-mo. And here's the student worksheet. And the first question I asked students was, why should you begin data collection after you start pushing it? If you notice, and there's where I brought in a little bit of physics, because we wanted the acceleration on the ramp to be only gravity. And if you gather data while the foam board is pushing it, or the ruler is still pushing it, you won't get good results. And the students record the data in the data table. They describe the trend in the data. And I do ask them to make a scatter plot of the data, because they may have, quite a few points. I ask them what type of function, and, it's so perfectly quadratic, it's really hard for students to miss it. But what I'm interested in, because I did it from 8th grade, I did it for Algebra 1 in using the x-intercept form to find the math model. And then in Algebra 2, I used the vertex form. And question 5, I'll explain when I show you some sample data, because the kids found great differences in the equations that each group got, and they didn't know why. And so we looked at the data in the first page here. These students, they did manage to get one x-intercept, but they weren't able to estimate the time very well, and they just wanted 7 points. They didn't care. They just wanted to get it done. And I've indicated all 3 forms here. Of course, you have to decide as the teacher, what level fits your students. Unfortunately, the 84 doesn't have a manual parabola. Man, that would be really great if it did, but it doesn't. But the data for these 7 data values, notice the student recorded 0.02, but the timestamp indicated the fraction of 30 frames per second. It gave a decimal, but not that small. I mean, 0.05 of a second. And I realized that the student misread the number in the timestamp. And so I'll show you how And I didn't catch it at the time, but I was glad that I didn't catch it because it gave me an opportunity to talk about, well, wait a minute, what was your, how was your data gathered? You know, was it frames or was it seconds? And so the, let me go back to the teacher notes here. And on the second page of the teacher notes, if I can get back there, my touch screen is not operating as well as I thought. I want to okay. Trying to zoom in on that. Top graph was a slow-mo video file that you saw earlier. The second one was a video editing software, the Camtasia. And the third one was downloaded from the same slow-mo file, but downloaded on the computer and analyzed on the computer. And there was a difference in the timestamp, but notice the difference in the equations that model the data. And that was my question to the kids. Why was that? And so I'm going to look at I'm glad Deb showed you how to make a graph of the data, but L1 contains the incorrect timestamp, and so the L1 was multiplied by 100, and I'll show you that graph, and you put it in second y equals. And I'm going to use the corrected data, the one multiplied. So I want list 3 for my X list and list 2 for my Y list. And when I graph it, here's the incorrect time. That leading coefficient is huge. But when I divided the time by 100, the leading coefficient got more manageable. Here is the X coordinate, and let me graph the data. And you have to decide whether you're going to use the automatic zoom and all that. But here's the data. If you click trace, I'm able to click through the data. I can find the vertex. I can find the x-intercept. And before this activity, I told the kids, I tried not to give too much direction to see what they would do. I said, be smart in the data values that you gather, because they would know which form that they were after. But I can't get to this x-intercept on the left. So I'm going to regraph it and not press trace, just press the arrow keys. Now I am
Marion, are
free
you
from-
showing your calculator?
Yes.
We're not
It's
seeing
on-
it.
Hmm.
I'm seeing teacher notes, page 2.
Oh, I have to change this share. Thank you for telling me that. Let's see. Share. Now I bet you're seeing my meeting.
No, I'm still seeing teacher notes, page 2.
Okay. Here we go. No. Oh, then it's frozen.
Marion, did you select share application or share your screen?
I shared the application.
That's probably why.
Yeah.
Because it's only going to show that one application that you're working on.
I'm going to stop my share if it will stop and share. Sorry about that.
Okay, now it looks like we're now seeing your, I don't know, mail inbox or something like that.
Oh dear.
Put on my glasses to see what it is for sure, but you can get to your smart view. We should be good to go.
Yeah, here it
Did you
is.
stop the meeting?
Here.
Oh, I see smart view behind you. There you go.
And if you use the arrow keys, you can estimate the x-intercept. And it's between 2.3, 2.35, or 2.34. And so when you go to your y equals, the x-intercept, this is a vertex form, sorry. And the challenge that I gave my Algebra 2 kids was change that algebraically to standard form and graph the two to see if they are equivalent. And here's the results of the vertex form. Now, I didn't get the kids got really good data with this. And if I go to Y4 and do the and graph that, it should show magenta on top of that. And so with the issue of time, changing all the graphs, I'm going to quickly show you the CBR. And the CBR gave the correct leading coefficient because those other values were incorrect. And I'm going to conclude this quickly. But notice that CBR is on top of the ramp pointing down to the cylinder. And you need to zero out the CBR before you gather data. And that's a simple process. It's very simple on easy data. But on the lower left-hand side here, you can see that if I use the data gathered by the CBR, because I know the CBR is gathering seconds, not frames per second, not 30 frames per second or anything, I get a very close to the accurate value of gravity in meters per second squared. And that made my physics go nuts. But the thing about using CBRs and with easy data is the tabs underneath. So you go to setup, you press by pressing the window key, and you select from the menu 0. And when you're ready, you press the zoom button, and it's so the CBR is gathering 0 distances in addition to positive distances and negative distances. And of course, I love to combine math and science. And I never did get a chance to do this. So if somebody wants to do this, change it into an open-ended math science activity by asking the kids open-ended questions like what factors would change the acceleration of the cylinder, and ask them to study it and study, okay, your group is studying that factor. And, the factors could be the different amount of push or the different angles of the ramp or the different diameter of the cylinders or the different weight. And you get some interesting results. I know that was a little bit complicated, but are there questions?
Say nothing has come up in the chat as far as questions. I like the fact that, if you don't have the CBR at your school, to collect the data, you could use the students' phones, which they all seem to have, that you can get a video and do it by just using a video. So, you wouldn't have to necessarily go out and buy new equipment to do this particular activity and get collection.
Well, the kids were really hyped up about using their phones in class because the
I'm
school
sure.
rule is you leave your phone by the door, So, but I'm glad that the CBR2 is my favorite math instructional technology by far because you can do so many things with it. Does anybody else do different quadratic data?
And say if they want to put that in the chat, they can here as far as that goes, if they've done good quadratic activities.
Okay, so you can take over while they put that in the
Okay.
chat, and because we're running
Say
low
while
on
they're
time.
chatting about their quadratic activities, I will start to share my information again in the activity. I know a couple people talked about when you said there was not a parabola manual fit on the calculator, and there isn't. That manual fit, as I said, is only usable for linear. So a couple people mentioned the transformation app, and I said we're going to get into that. So I want to have time with this activity of how much is that car in the driveway, of showing how to use the transformation app, because a couple people even asked what the app was. So again, looking at the activity, this is an activity I started using with my honors algebra 2 class. That is a sophomore level class. And usually sometime in the sophomore year, they're starting to get driver's licenses, or will be very quickly. And where I live, as soon as they get their license, they seem to get their own vehicle. They didn't have to borrow the family Woody wagon like I did when I got my license back in the day. And so they were interested in cars. So what they had to do is to pick some kind of car, and I let them pick anything they wanted to, whether it was what they knew they were going to be driving or what it would be their dream car. And over the years, I had everything. I had Vets, I had Lamborghinis, I had Maseratis, and I had the Astro vans and the little BW bugs and everything. So I didn't care what they were. They just had to pick the make and the model of the car. They had to then go on their own and find at least 12 to 15 different vehicles, but that were not more than 10 years old. I learned through a mistake when I didn't say that they couldn't be more than 10 years old. Somebody was doing Vets and they got into ones that were 15 and 20 years old. And we really ended up with more of a parabola than what we were supposed to, because the antique value of a Vet, they go back up in value. So learned from my mistake, limited how old the cars were supposed to be. But the other thing that I did with that is at that point, when we start talking about the scatter plot, they would not have a function for their scatter plot because they're going to have some repeated data. And that's also going to affect what the graph is going to look like. If they have to have at least 12 vehicles, but none of them can be more than 10 years old, they're going to have repeats in their years. So again, I ask that they go to different sites, whether it's the internet, which is so easy to do now with all of the car internet sales sites. I try to encourage them to go to local dealers, call a dealer, see if they could get a dealer to find a price for them as far as that goes. And that kind of thing. So they would have a variety, and no, it wasn't just something that was made up. I also had to learn from my mistakes and say they couldn't use the Kelley Blue Book, because one year I had a student that got like 10 of their 11 or 10 of their 12 data pieces from the Kelley Blue Book. And they had a wonderful scatter plot and a line of fit that went through every single point, because I realized that Kelley Blue Book really uses this regression equation as far as that goes to come up with possible prices and suggestions. So once they had their data, again, they had to, make a scatter plot. This is an exponential type of equation. So I reminded them of what the exponential equation was to come up with their line of fit. And then again, I had them answer some questions, write a summary of their activity. I gave them a chart to fill in their data, the questions, domain and range, observations about the scatter plot. What is your line of fit? Does it have an X or Y intercept? Why is that the case? Thinking about exponentials and things like that. And again, some of these prediction equations and things like that at the end. Again, I did this to begin with my honors algebra 2, and it was a complete project. It was the end of the year. I gave them this. We talked about it in class, and then they were on their own. I might have given them some time a couple of times in class. Okay, make sure you bring your stuff tomorrow. We're going to have 15 minutes that we're going to work on your activity. But they had to write up a paper, and they actually turned in a 3 or 4 page paper with their graphs included and their conclusions and things like that. In my regular algebra or my basic algebra 2 class, a lot of times I would give them the data, or maybe I'd let them collect their own data, and then we would do it in class and things like that. So again, using this data, oh, I guess I did this. I just took some information from one of my students for a Honda Accord, and this was the data that they had collected. They looked at cars that were from a new car like the last one that was really 0 years old up to like 9 years old, and they had the data. So again, I have preloaded my calculator. You will get the emulator state again for this. So if I go to stat edit, I stored them over in 5 and 6 this time just to save a little bit of time. So I had my data from my previous activity in 1 and 2, but I have my data from my car in 5 and 6. And if I scroll down, you'll see I have that last entry of 0 with the 21,995 for the price sort of a brand new one. Again, if I go to my stat plot and I make sure that my stat plot is on, okay, I've got my X list as 5 and my Y list as 6. Setting up my graph, I have my window, and again, I've preloaded it. I have a -2 for my minimum. I have 15 for the age of my cars. I went a little bit above my 10. Again, I know my one question was, if you had a 12-year-old car, so I went beyond that so that maybe I could trace on my line and see what it would be. My Ys went from -10 to 25,000, so I was more than that most expensive car, and a Y scale of 2,000. So now if I hit graph, we have my scatter plot. Again, you can see that my axes are showing up, X and Y, because of having those negatives. Looks like there's a sort of a curve. It's supposed to be an exponential equation. If we were to make conclusions about the scatter plot, hopefully I would get them to say that it's not a function because I have a couple of X values that are the same. It generally goes down to the right. It looks like it might be this slope is decreasing more rapidly at the beginning than it is at the end, that these are almost in a straight line and things. That's the way it's supposed to be coming up and hopefully being exponential. So there's my scatter plot. Now on to the transformation app, because as we said earlier, can't use that manual fit. It's not linear. I want them to use the transformation app. And again, if you want to in the chat, you can talk about whether you've used the transformation app or not. I'm going to go to the app button on the calculator. I'm going to up arrow because the transformation app is the very last one that is there. So if I hit the enter key and turn on my transformation app, and the instructions tell me press any key on the calculator just so that we can get into it. So I'm going to go to my Y equals key. Oops, not hit Y equals. Oops, I got my old equation in as far as things go. So I'm going to clear that out. I know I'm in the transformation app if I have the color calculators, the CEs, because it tells me I'm in the transformation app. I see I've got quit app. And a real clue that I'm in the transformation app is also these funky little symbols over here to the left of the Y equals. Okay? And in the newer operating systems, there are only 2 of those. In the older operating system, you might have them going all the way down through all 9 of the equations. So again, if you have more than the 2, you might want to update your operating system. If you have this funky symbol, that means that Y equation can have a formula put into it. I could type other equations in down here, and we could test some things. So if I go to the left of my Y1, I get a box around that funky symbol and my color, and I hit enter. Again, my scatter plot was in blue, so I'm going to change my color, and I'm going to use green for this. That's because it's the school colors, and I know what's in my slide. Okay, and whoops, I went past that. If I go down to where it says no for Y1, We'll talk about that in a minute. But if I use my right arrow, there are now, again, with the newer operating system, some preset equations that you can use as your formula in those first couple of Y entry lines. There's linear, there's quadratic, there's the vertex form of the quadratic, the x-intercept form, standard form, cubics. They have an absolute value equation, a sine equation, a cosine equation. The transformation app is a wonderful thing to use to help students learn on their own what the different numbers do to a particular equation and how it transforms the line based on the numbers in the equation. So again, I could use a preset equation. Unfortunately, in the preset equations, there is no exponential. So that's why there's that no idea. And so it takes me back to here, and I can type in any equation I want to. It used to be you had to type in all of your formulas, but now they have those preset ones. So I'm going to type in my basic exponential equation. I'm going to go alpha. Oops, I think I hit second. No, I didn't. Alpha A multiplied by alpha B raised to the x power. And I'm going to get out of my equation. One of the things, if you're typing in your own formula, you have to use the variables of A, B, C, and D. If you were going to do this, and you could use the transformation for a linear, you could not type in mx plus b. You'd have to type in ax plus b. And you'll notice in the formula, that's how it was set up. The other thing I might want to do is make sure that I'm starting in the right spot and a basic idea. So I'm going to go up to my window key, go to the up to the window, over to the settings, and I want my A to be a value of 1 to begin with, and I want my base to be a value of 2, your basic exponential. And now when I graph, okay, I have my scatter plot, I have my formula up in the left-hand corner, and I've got A and B values listed. Up and down arrows highlight the equal sign, and if I change by going to the right, I can change my B value to 3 and see what happens with my equation. This is what makes the transformation app so powerful. I can also type in numbers. So I'm just going to go back and set that at 2. All right. So now I need to say, okay, well, that green line is not a good fit. So what might I need to change? My A, my B value, any suggestions? If you can real quickly in the chat, we don't have a lot of time left here, but I want to see if we can get a pretty good idea and see how to use the transformation app for an idea. Okay, do I need to change my A or my B value? Which one do we want to start with? And I will say most of my students start with their intercept value, and we've done enough look at it. And I think I'm seeing that A needs to be a negative.
Quite a variety of answers.
And one I saw was A was negative. And this is the advantage of this. So if I type in A is -5, what happens? Ooh, my whole graph disappeared. That's not good. So I'm going to go back to my 1. Need to remember that in this particular case with an exponential, what represents the y-intercept? The A value or the B value? And again, it might not have worked with exponentials for a while, but it's a little bit different than what you think. The B value affects the curve of it, and the A value is what affects the y-intercept. Right? So I'm going to change my A value to, again, I could trace on my points and figure out what this first point is here, or what do these two tick marks represent. But I'm going to type in that price of a new car, or what was close to it, which was like $22,000. If I hit enter, I'm going, oh, good. That does put me at a y-intercept, but now my curve's going the wrong way. So the A is what is the y-intercept in your exponential, and my B value, if I don't want it to be going up to the right, but I need to have it going down to the right. And again, those of you that have made more work with the Algebra 2 and the pre-calc maybe, what does our B value need to be? And I know what my students always say and start with, because we've stressed it with all of our other equations, is, oh, my B needs to be negative. So I'm going to type in a -2 for my B value. Well, again, it disappears. And, well, keep in mind, what a negative value does is reflects things over the x value or the x-axis. So I've switched from my exponential being in quadrant 1 and 2 to my exponential being in quadrant 3 and 4. What I should have, and hopefully somebody has put it in, maybe is that it is a fraction or a decimal is needed. So if I type in a B of a 0.5, oh, at least I'm going down to the right now. But it's still too much of a curve. I need to have it more gentle. Do I need to increase or decrease? Be closer to 0 or closer to 1? So let's try 0.9 and see what happens. Oops, I put in 0.0. Let's just type over it. 0.9. Okay. Well, that's getting closer. Okay. Got a lot points above, or points below. Maybe we can tweak it a little bit and go 0.85. And again, you can get as, oh, that's a good curve, but now I'm not high enough. So maybe I need to increase to 24,000. And again, oops, I think I did too many of those.
Yep.
So back over that
Too many
and
zeros.
delete that 0 here real quickly, or we'll be off the grid again. So I'm getting closer. And again, you can just keep typing in and trying. And what I like again about the transformation app is I'm doing this all on the same screen. I can adjust my numbers and see immediately what it's doing for my graph of things and stuff like that. So if I real quickly go back to my presentation here, oops, okay. I thought I had, I guess I didn't, pictures of what the graph looks like and things like that. And we only have a couple of minutes here, and I know that we have to get back to Wendy, but any quick questions or comments about?
I didn't see any questions. I saw lots of great suggestions for answers and that kind of thing.
And say, and I know I rushed through. Normally I'd take suggestions from the audience, but I know we're getting close to the 3:15, 4:15 stop time here, and want to make sure that we have time to announce our winner and that kind of thing with stuff. So hopefully you got something from this, whether it was new activities to use, different ways of using activities, maybe something new with the calculators, whether it was manual fit, how to find those x-intercepts with the quadratic, and get some ideas that can be used.
And the CBR2.
And the CBR2 and activities that can be done and that actually worked and in the classroom.
Oh, I don't know if you've been following the chat, Deb, since you're busy.
Say I didn't. It popped up every once in a while, but I couldn't read it.
Okay. So I picked out a winner at basically at random because I was scrolling through the names back and forth. But I picked. Can I announce the winner now?
Go ahead. Yes, go ahead.
Okay. Oh, drum roll. Rit Brill, you have become the winner.
Yay, Brett.
Well, thank you, Marion and Deb, both for that presentation. I know it looks like everybody got some good ideas out of that. And I did mention in the chat, in case you missed it, if you do not have a copy of that emulator software that our presenters were using, this is a list of your local TI reps that can get you a free copy of that. And that is located on that particular link that's at the bottom of that slide there. And that way, when you go to that link, these names are actually active and it'll take you straight to their email addresses. So feel free to reach out to them. And if you need some ideas or would like them to come visit you or anything like that. Also, just a reminder, this session was recorded and you will get a link via email next week that will have a certificate of attendance as well as information on accessing all of the documents that Marion and Deb presented, as well as a link to the video. So if there's no other questions, we appreciate you guys joining us today. Hope y'all enjoyed the conference and got some great ideas for your classroom. Have a great rest of the school year.
Bye.
Bye.
Bye-bye.
Baby, good work.